Last time I posted a video, I talked about using Draw.io to create component diagrams, and I started to illustrate a proof of concept for using interfaces to define boundaries of these components. What I'd like to do today is kind of slow it down a little bit, make a shorter, quicker video, and just really talk about how to use interfaces to create boundaries. So if you think about the word interface, it's well, it's a boundary. It's the facade in which you interact with a thing. Imagine a user interface or some sort of panel on a machine with a bunch of buttons. You see the buttons, but you don't see the machinery underneath. So your way of interacting with this machine is through this interface. Well, one of the challenges as a developer is you might be working on a team where someone else is building a thing that you depend on, or maybe there's a third-party component that you want to use that you haven't decided, but you do know what you need to solve for. So I'm going to use this recruiter manager that I kind of drew out before and use this as an illustration. In fact, I'm going to focus exclusively on this guy and its needs. So I'll exclude this gateway interface to the recruiter manager and focus on developing this thing. So once again, I'll start with the story of this example that I'm going to build, and then I'll use a little bit of test-driven development and coding to show how this happens. So the idea is you've got this concrete class. It's a recruiter manager, and its purpose in life is to get recruits, and from those recruits, or this pool of recruits, it needs to get an employee. So its purpose to the rest of the world is get an employee. The way it does that, though, it depends on some sort of pool of recruits or recruiter pool. The problem is at development time, we don't know what that pool is going to be. We talked about it a little last time. In this diagram, we assumed that a recruiter might reach out to a school and get students and convert them into recruits that could be turned into employees. But schools aren't the only kind of places that you can get recruits. You might go to a boot camp, or you just might simply put an application online and someone who's self-educated is qualified for the job. So the key here is that the recruiter manager class knows nothing about the implementation of the recruiter pool. It just knows there has to be one. So it knows that there's an interface called iRecruitPool. It could be called whatever you want it to be, but for this example, I'm calling it a recruit pool. So here's the interesting thing, though. Sure, recruiter manager needs to know that this concept of a recruit exists, and it needs to know that the thing it's going to turn that recruit into, an employee, exists, but it doesn't need to know what the recruit pool is going to be. It could be anything. So what you do when you don't know what you're going to develop is you create a mock. Let's call that a mock recruit pool. And this arrow is going to be actually pointing up because mock recruit pool will implement this interface. And the thing is while you're developing, you're going to use unit tests to help you write this code. And through unit testing, you're going to be able to create a mock recruit pool. Now, when you create a mock object, you're not building all of the things that this mock object can do. You're just mocking up just enough to test the use case of this interface. So in the future, though, you might actually have an actual implementation of that. And maybe it's school recruit pool, right? Let's delete that line. The arrow should go up. So in the future, there might be a concrete class implemented either by yourself or by another component that implements this iRecruit pool. Now remember, Recruit Manager doesn't know that. It doesn't know the difference between a mock or an actual school recruit pool. Well, what happens if you're getting a third-party component and school recruit pool implements some other crazy interface? In fact, I'll just draw that. Because third-party companies don't know about your expected interface, they know their interfaces. So this thing would actually be implementing this interface, and this is developed by some third party. Well, we still need our interface because we don't know it, nor do we care how they implemented their recruit pool. So what we do in this situation is we might create an adapter component, or an adapter class or a component, and it could be a and the way that would work is Recruit Manager would consume this thing called iRecruit pool, which would happen to be implemented by our own adapter that we build, and our own adapter would effectively call this third-party school recruit pool that doesn't exist yet, and it would effectively map this concrete object with this interface into an implementation of our own iRecruit pool. So what that means is, regardless of whether we have some third-party thing or we own it, a concrete thing, or we're testing with a mock object, we can trust that this interface will exist. So what happens is this interface behaves as a boundary. Sometimes a boundary can be illustrated as a double line going across. So this is the boundary of this chunk of code. So the real important thing here is that yes, you can actually build with 100% confidence what Recruiter Manager is going to do without knowing how it's going to be implemented by coding to this interface. And the key here is to test it by using mocks. All right, so let's go ahead and move to some code. So I've set up this project here, and it's just a simple solution. We've got a recruiter component and a recruiter.tests project. So normally I would do full TDD and just kind of build up this unit test. I'll kind of run through it and get to the important parts though here, and really illustrate how to get those boundaries defined. So the first thing I'm going to do is I'm going to go to my diagram, and I need a recruiter manager class. So really I'm testing a recruiter manager. Visual Studio is kind enough to rename it for me. And one of the things I like to do is, it's kind of like a heartbeat test, but really I like to make sure I can instantiate the thing first. So I'll write a test, recruiter manager should instantiate. I'm trying to follow this, I guess they call it the shouldly syntax, where it's like underscore should do a thing, underscore when such and such. So usually the first chunk will be the method name, but since the method, we're testing the constructor, the method name is the same as the class. Well, the problem is the class doesn't exist yet. So we're gonna do a little TDD, and should look familiar if you've done any unit testing. Arrange, act, assert, the 3 A's. So I kind of work backwards here. What we really want to do is assert that recruiter manager is not null, that it can be instantiated. Of course, recruiter manager doesn't exist, so we need to create one, and that's what acting is doing. We're going to and there's nothing yet to arrange. That'll come later as we kind of flesh out what it means to instantiate a recruiter manager. So at this point, as you can see, we're practicing red-green refactor, right? Red is first you write the test and verify that it cannot pass because you're verifying that you're only writing code that is needed. And then you write just enough code so that it passes, that's the green. And then refactor, you clean up the code with tests that pass so you can trust your refactoring. That's red, green, refactor. So right now we're in red. In fact, we're not even really at red. We're at red squigglies. In other words, this object doesn't exist yet. So what I really want to do is I'll go to this recruiter and I'm going to add a class and call it recruiter manager. I'd like this to be able to be internal because we're not going to be calling this class directly, at least not yet. So the problem is we need to be able to make our unit tests. We need to be able to unit test internal properties. So the way we do that is there's a property that you can add to your project. Okay, so what I just did here is I opened the recruiter project file and I added an assembly attribute that will allow internals to be visible to this project, the recruiter.test project that we just created. So there are other ways to do this in .NET Core. You can decorate individual classes, but since I'm trying to test all the things, I figure I'll just set this once at the project level. And what this does is at compile time, this actually outputs to what would be the assembly info file that we used to use before. So now that I've done that, my unit test can see internal classes and class attributes. So if I go to my test, I should be able to add a reference to that. Of course, we need to add recruiter, the project, as a dependency for recruiter.test because that's what it's testing. So the way we do that is we add a reference. We click on projects, we see recruiter as an option, we hit OK. And then we can go to our tests and the red squiggly goes away. So now we can instantiate a recruiter manager. So I'm going to do a build, and it's probably a little redundant, but I always like to see the build succeeded. And now I can go to my test explorer and I can execute my tests. So I see that there's an eligible test, and this is the test that I want to verify. So I'm just going to run all my tests. And every time I make a code change, I want to run all my tests to verify that they work. So this is kind of the hello world of this, this class is just doing an instantiation. So we'll carry on. Now we have that test. We want to go ahead and go back to our diagram. Well, we want to verify that this recruiter manager can get a recruit pool and get a list of recruits back. So we'll write a test for that. I'll just copy and paste this. And now we're going to use a method name. So we're going to call the method getRecruits. And they should normally I would do these tests in a more smaller incremental way, but I'll go ahead and just kind of get to the essence of it. So, all right. Okay, so we're going to assert that we can actually get some recruits. Well, what is a recruit? I like to work backwards. Well, a recruit is, well, let's define it more explicitly. We know it's going to be a list of recruits. And we're going to get those recruits from the recruit manager. And so we need to, here's an arrangement we can do. We can arrange to create a we've got this recruiter manager, and we want it to be able to be called, and we want to call a method called get new recruits. And what you call these methods and the business rules for those methods, this is subjective. This depends on the business rules that you land on. So what I'm doing is I'm basically reflecting the business rules that I sort of see being played out here. If you're doing more of a behavior-driven design, you might have stories actually typed out, and then you write your tests to illustrate the individual behaviors. And I think that's a great way to write code. So as we can see, we're not compiling because, well, first of all, this thing needs to know about lists. So we're going to do using system collection generics. So that takes care of that. The next thing is it's like, hey, I don't know what recruits are. So we need to add a recruit. And actually, we don't make the individual item plural. We would make them singular. So we need to create a recruit object. Normally, I could just generate, but I don't want to generate the new file in the test project. So I'm going to go to the Solution Explorer, go inside a recruiter, and I'm going to add a new item. Let's make it a class. We'll just name it recruit. So now we've got a nice little recruit. Well, this recruit, if you look at our diagram, it's going to be part of the border of this interface. So whoever implements this, and I should have illustrated this here. Whoever implements this guy, they're going to depend on recruit, just as this guy would depend on recruit, because this is going to implement a thing that returns this to this. So I'm going to go ahead and delete these guys from the diagram just to clean it up a bit. So right now we're creating this recruit, and this recruit is part of the boundary, so therefore it should be public because other DLLs need to be able to see that model that they are expected to return. So we'll go ahead and make sure that this recruit is public. You don't want all the things to be public, you just want the things that are part of the boundary to be public. So now we've got this recruit class. We can new it up. So now we need the manager to be able to create it. At this point, because this manager exists in code, we can use our shortcut, generate the method, and go to that method, go to definition, and its goal is to return a list of recruits. Well, we're going to write just enough code so that the unit test pass. So I'm going to return a new list of recruits. And that should be enough for that unit test. So if we go to our test explorer and we execute the tests, we should see this guy also passes. So that's neat, but that's not really helpful because, well, as you saw, we just returned an empty list, and that's not sufficient code. So we need to write another test that proves that this thing can return the kind of objects that we expect. So I'm going to go ahead and write another test. I'm going to get rid of these guys. Now here we're going to say get recruits should That might be a little verbose, but I like verbose. There's no confusion about what's going on. So get recruits should retrieve equivalent pool of recruits. So in other words, we're going to have an expected list of objects, and we're going to compare and verify that this thing can actually return that. And here's where it gets interesting. Here's where we play around with dependency injection. So first, let's define what we expect to be returned. So the neat thing is it already knows that recruits existed because in our previous test, we wrote that part of it. And that's the nice thing about taking baby steps in your unit testing is the unit test should test one thing and one thing only, and that lets you build up the code incrementally in the smallest pieces necessary. So now we want to just have some new recruits back. And I'm just going to put some, we'll new up a recruit. And C# abbreviation where you can just put it in line. At this point, I'd like to define some of the actual properties. So I want my recruit to have an ID. And since these are mock recruits, we're not actually calling a service or hitting a database, we get to define what we want them to be. So I'm just going to create I'm going to say that ID should be a GUID, and I expect, I'll go ahead and use new GUID. Well, there's a couple problems there. So I need to be able to, using system. So now I can create an ID. And this ID doesn't exist yet, right? So if I hit control period, I can generate property recruit.id. And just to go, sometimes it takes a second because it's actually writing that. If I go to definition, I can see that GUID ID has been added to that recruiter.recruit file. And it's also opened over here. And let's save. I'm going to go ahead and do remove sorting, and I like to clean that up and get rid of unused usings. I'll hit Control Tab, and I forgot to save that file. Control Tab, and go back to the file I was working in. I'd like to add a couple more properties, just real simple ones. Last name and first name, and I'll put my last name in there. Why not? And as you can see, those properties don't exist either, so we can generate property and generate property. And that's the really neat thing about doing test-driven development is the IDE of Visual Studio, it's built for test-driven development. It has all those little wizards that help you write the code for you. So as you can see, it wrote all those properties. You notice I didn't do a whole lot of code writing here. So take a glance at this and make sure all the IDs are right. All the types are correct. We got a GUID, a string, and a string. That's perfect. I didn't even think to limit the setting to internal, but it was smart enough to know that when I do a get, well, it needs to be public, but when I do an internal or a set, it needs to be internal. So as the scope needs increase based on the tests that we write, we can just simply refactor. And the trick is to really trust that refactoring process. So let's add a second recruit in here just so that we can verify that we can return a list of the thing. So once again, now you can see IntelliSense is kicking in and you can see the properties show up. Okay, cool. So this is what we expect to get returned. If we call that property, let's call, well, actually we need to generate our manager. So why don't we do that too? I'm going to cheat and steal that instantiation. And this is just like our last test. So I'm going to call that method and I should be able to assert that it's, well, I want to do more than just assert that it's not null. I want to actually assert that it equals, that the recruits that are returned by this list of recruits equals the expected list of recruits. And there's a really, you could create a new object and compare them one property at a time, but there's a really neat library that I like to use. If you go to recruiter test, we're going to add a dependency, and this is available on NuGet. I believe it's called Fluent Assertions. And there's a couple other libraries out there. Deep equals is one I used to use. But what that does is it gives you, Fluent Assertions is, lets you do entire object comparisons, but it does it in a syntax that's very expressive and readable. So now that that's been added, and while I'm at it, I'm going to go ahead and add mocks, because we're going to do that real soon here. So here's a common library you should always be using, or at least a similar library, and we'll go ahead and install that. And accept all the things. Cool. So now that I've added Fluent Assertions, I can do a more meaningful assertion. In this case, I'd like to assert that the objects are equivalent, and that's why I use the word equivalent here. So we should retrieve an equivalent pool of recruits. And the reason why is if you create two objects in C#, and you try to compare them one to the other, they have different pointers because they're reference types. So you're not actually going to ever have equal pointers. So what you really want to do is compare all the scalar values, the properties, and it kind of, to do that, it iterates through the object and looks at all the common property names and makes sure that the values are the same. So we start with, it's very semantic. So it goes expected recruits dot should. You notice it didn't pick anything up, so I go period use fluent assertions, and I hit control period there, and it's now been added, so I can do be equivalent to, and it should be equivalent to the returned object, which is recruits. Cool. And at that point, I don't need this test. This should cover it. Now, I'm going to go ahead and run this test. First, I should compile, make sure everything is good there. Now, we know that this test is going to fail because we didn't actually implement anything in this method. We're returning an empty list. But at this point, we're going to go ahead and test it, verify that the test runs. We want to see red. Red being that if it fails, and that's good. Red, green, refactor. First it's red, then we make it green. Well, the first thing is let's look inside here and find out why it didn't pass. Well, this is a really cool thing about the Fluent Assertions, is it gives you a very detailed explanation of the individual properties that didn't match. So let's take a look. We're going to go to get new recruits, go to definition, and we want it to return this thing right here. Now what we could do is I could just straight up copy this and return a new list. But there's a problem. You see how I'm newing up that GUID? Well, it's going to be a different GUID every time you new it up. So let's try to execute and see what happens. And here we can see, okay, we're a little closer, a lot fewer errors. Now it's just the two individual properties, the IDs that don't match. So we're a bit closer. But how do we get the exact objects to get injected into this manager? Well, that's just it. We use injection. So let's look at our diagram. We need a recruit pool, and we need to inject that recruit pool into a recruiter manager. So let's go ahead and create that interface first of all. And we're going to go ahead and make this interface public because it's part of our boundary. So just as the recruit model was part of the boundary, so is the recruit pool. In other words, the things beyond the boundary, they need to know that these two things exist and be able to use them. So we've got this interface. That's kind of cool. So what do we do with that interface? Well, we need to be able to inject it into our recruit manager. So I'm going to use TDD to do that. Let's see if I can be clever with that. Now that I have an interface, I can mock that interface up. So let's create a mock recruit pool. And it's as simple as new mock. And here it's saying, I don't know what it is, so control period. And it'll say using MOQ, mock. And then here it's expecting a generic, so you can pass in what it's going to be creating. So it's going to create a recruit pool. And for now, that's good enough. We want to just take that mock recruit pool, it's a tongue twister. And the trick here is you go dot object. So the problem is, as you can see, from the red squigglies, that this constructor doesn't know what this is. So that's okay. It's got a little helper. We're going to generate a constructor for recruiter manager. And look what it does. This is kind of neat. We're going to go to definition. And we've passed in the recruit pool, and it's got a backing object. Now, I didn't like how it named everything object, so let's do this one step better. I'm going to undo that. And it's going to, instead of just trusting it to name it to something generic, I'm actually going to explicitly set the property. So we'll say, there, recruit pool. And it's saying, hey, I don't know what that is. So take a few seconds to refactor. Then we'll go to definition. And here, this is really neat. You have a constructor with dependency injection. It's setting this recruit pool to a backing property. Sometimes people will set the private properties with an underscore. I'm just letting TDD do its magic. So let the .NET standards tell me how to write code. So I'm going to do a remove and sort usings, clean this up a little bit. I'm going to go back to my test. I'm going to verify that this code can compile. So there is no argument. Oh, okay, so this is good. Now my code stopped compiling because over here, I had 2 unit tests that wasn't using a recruiter manager. So I could just pass null in, see what that does. And heck, I should even be able to test those. We know that this will still fail because we haven't implemented the get new recruits. We've just added the dependency that we're going to use to implement it. But before we move any further, let's test those other unit tests and see if those pass. So those still pass. So apparently just passing null in is okay. So what that's telling me is that, hey, it's okay to have a null recruit pool object being injected in there. Well, I don't feel good about that. So I'd like to throw an exception. And normally I would write another unit test that would, I'd write another unit test for that exception. I'm just going to cut a few corners here. And I'll just say if it's null, I will throw. I would also normally create a custom exception for this component, but that's out of scope of this demonstration. So I'll just go ahead and throw a typical argument exception, and it has a parameter of, we can just name the parameter it's missing. And that's helpful. So if null is passed in, this should fail. So these should all fail now. So let's run it. And there we go, they all fail. And that's good because we just added a null check. So null should not be good enough. So what we need to do is we need to create this proper mock object and pass it in. And that's where we go back to the arrange. I'll add it to both of these guys. Might help if I put dependency in front, the thing that's actually using it. Cool. So now we're actually instantiating the recruit pool, the mock recruit pool that we're passing in. We're not defining anything about it. We're just passing in a mock, and it doesn't do anything, and that's okay. So let's make sure those other 2 unit tests now pass. First, the code succeeds when you build it. Run unit tests, we expect 2 to pass, that's good. Now we can dive in and go, okay, why did this still not pass? Well, it failed because it still doesn't like that we have differing IDs. And that's because we had hard-coded this new list inside of this method. So if we go to definition, we can see we're just straight up returning this list. Well, that's kind of annoying because, well, not annoying, it's telling. And what we really want to do is we want to create a list of recruits from our recruit pool. And well, what the heck, we'll just give it the same name, get new recruits. See, that's the key here is comment this out. Now, we, as the owner of this interface, get to decide what that interface is going to do for us. And well, we want it to return a list of recruits. So we get to do generate method. And if we go to this interface, we can see that it created the expected contract for returning a new list of recruits. Once again, I'm going to clean up my code, save that. And then I can go back to my manager, and since this is returning a list of recruits, and that's what I want returned, well, I'm going to go ahead and just return recruits. And I'll get rid of that hard-coded code. So at this point, once again, we expect the code to compile, and this is really all the code we need to write in here for now to get that unit test to work. But the problem is we never defined that mock recruit pool's definition of get new recruits. So let's show you how that happens. Well, let's go back to our unit test. And I'm going to go ahead and run the test again just to verify that it fails. It should fail. And it does. In fact, it not just fails, it another test over here failed. So let's find out why that failed. And it says is not null failed. Oh, okay, cool. So what is happening here is we changed the definition of get new recruits, and before it was returning a hard-coded list, and therefore this was never null. Now we never implemented this mock, so this recruit list is now coming back as null. Well, we're saying we don't want that to be the case. So let's go ahead and clean that up a little bit. So what we're going to do is if recruits is null, we're going to go ahead and just return an empty list. Because returning null, it's not a really good practice. We either want to return the thing that we expected, or we want to be able to throw an exception. So here we'll go ahead and, well, since it's a list, we can trust that an empty list is workable. All right, so it's what that's saying is if recruits is null, go ahead and return a list, an empty list. So let's build that. Let's test it. This should now pass. And now we're back to that one test that we're trying to complete. All right, so, so we still have something missing. We still need to implement that one method. So the way we do that is we've newed up our mock recruit pool object, but we need to set it up. So we're going to go inside of mock recruit object, or mock recruit pool, and we're going to do dot setup. And this is really neat. It's uses Lambda expression, so we'll have our RP for recruit pool, and we're going to say when you call recruit pool dot get new recruits, we want it to return, and this is expected recruits. And that's kind of all there is to that, just for readability. I love method chaining, but I also like to tab it down so it's easier to read. So we're going to set up this method and have it return these things which are defined up here. All right, so now when we execute this code, let's see what it actually returns. So build succeeded, and all our tests pass. That's really cool. Okay, so what we've just solved there, let's go back to our diagram. So we've done dependency injection where we've passed in the recruit pool, and we have said that I expect when I get recruit managers that it's going to return a known list of recruits. And the way we define that known list is we pass in this mock as a dependency. This mock implements this interface, and it returns a defined list of recruits. So The next step would be for me to implement a method on Recruit Manager that maps those recruits to employees, or lets you search employee or convert an employee from a recruit by ID, or maybe we need to start writing more methods that evaluate recruits. And that's part of the business rules that live inside of the Recruiter Manager. But as you can see, we were able to implement a recruit pool without having an actual recruit pool defined. So if there's another team building that recruit pool, we don't have to wait for them. We can code with complete confidence what we expect. In fact, we should be defining what we expect because we are defining the business rules for Recruiter Manager. So, all right, I hope that helps.